Today's lesson is about adding fractions and mixed numbers. So on my next blank page of my math notebook, I'm going to write the learning target. I can add fractions and mixed numbers. I'm also going to include in my notes the date, either in the upper right-hand corner or the upper left-hand corner, whichever your teacher prefers or whichever you prefer. One of the things that you should already know about adding and subtracting fractions and mixed numbers is that you should always have a common denominator. So let's make a note of that. And at the risk of oversimplifying this, I want to do just a quick review of why I need a common denominator. So if I had a problem 1/2 plus 3/4, and I was adding them, one of the first things that you might have done when you learned how to add fractions is that you might have made area models. So I'm going to make an area model. I'm going to make two rectangles, two whole rectangles. And now I'm going to make them into parts. So to represent this fraction, I know that the denominator tells me how many equal parts the whole is divided into. So I've divided it into 2 equal parts. And the numerator tells me how many of those parts I'm interested in. So I'm going to shade one of the 2 parts to represent 1/2 of that whole rectangle. For the second fraction, the denominator tells me that I have 4 equal parts, so I'm going to split that rectangle into 4 equal parts, and the numerator tells me that I have 3 that I'm interested in. So I now have this area model that represents that addition problem, and I know that I have 1, 2, 3, 4 shaded parts. But if I were to say that I had 4 shaded parts, the next question would be, what would the denominator be? Would the denominator be halves or would the denominator be fourths? So you've learned in the past that you have to make them the same size in order to be able to combine them. So for example, I could make this 1/2. I could split that into 4 equal parts, but now I have 2 of them that are shaded, and then I have 3 that are shaded over here. So I've changed my 1/2 into 2/4, which is an equivalent fraction that has the same denominator as my other fraction. So if I add 2/4 plus 3/4, I'm going to get 5 shaded sections, 1, 2, 3, 4, 5, and they are all fourths, so they're all the same size. So the reason why I'm changing it to a common denominator when I'm adding and subtracting fractions and mixed numbers is that in order to be able to combine them, they have to be the same size first. I'm intentionally using that language because that will come into play again when we add and subtract like terms in our pre-algebra unit. We'll learn that they have to be alike before we can combine them. So they have to be the same size before we can add them. When I'm adding fractions, I end up with 5/4, and I want to be able to express that as an improper fraction, which there is a place for improper fractions, but I also want to be able to express it as a mixed number. So in order to change it into a mixed number, this is also a skill that you should have, but just a quick review of it. In order to think of it as a mixed number, I want to think of this fraction as a division problem. So every fraction is a division problem, and every division problem is a fraction. I can divide 5 by 4, and if I divide 5 by 4, 4 goes into 5 one time. 1 times 4 is 4. 5 minus 4 is 1. So my mixed number is going to be 1, because I got one whole group and 1/4. And many of you just know to ask how many times does 4 go into 5. That gives me my whole number, and then I have one piece left over, so it's 1/4. So I want to be able to express my answer as either an improper fraction or as a mixed number. And we'll learn that it will depend on the situation which of those is the final form that I leave my number in. Alright, so for a more complicated problem that is a better representation of what we're going to ask you to show us on the practice, I'm going to give you two mixed numbers and ask you to add them. One of my first recommendations is that you put it in vertical format. So I'm going to change this from horizontal to vertical. That's not going to be as important when we're adding mixed numbers, but it becomes super important when we're subtracting them. And then I'm going to look for a common denominator. So to find a common denominator, I'm going to multiply my fraction times a big number 1. So notice that that looks like a 1. And in that 1, I'm going to divide it into two parts, the numerator and the denominator. First of all, I'm going to ask you, what do you think the common denominator should be? So you would have identified the common denominator as 40. And now I need to take each of these fractions and give them a denominator of 40 by multiplying by the big number 1. So this big number 1 is going to be 5 over 5. Because 8 times 5 is 40, so I also have to multiply the numerator times 5. And down here, my big number 1 is going to be 8 over 8, because 8 over 8 equals 1. But 5 times 8 is 40, and 4 times 8 is 32. Once I have a common denominator, I can add the 5 plus the 32, get 37 40ths. And I don't want to forget my whole numbers. I still have a 3 and a 2 that I can add together. And my answer is 5 and 37 40ths. Notice on this problem that I did not change these mixed numbers into improper fractions. And one of the things that we sometimes see students do is when they're adding and subtracting, they change the mixed numbers into improper fractions. It doesn't make it wrong. It just makes your numbers big and hard to work with. And there really is no reason when you're adding and subtracting to change them into improper fractions, unless you see a very limited reason tomorrow when we're subtracting mixed numbers and you have to do some regrouping. But for the most part, we want to leave them as mixed numbers and not improper fractions. Our next example will be 5 and 5/7 plus 6 and 5/9. So again, I want to write it horizontally. I want to find a common denominator. I want to, as I'm finding my common denominator, I want to use that big number 1. So this is going to be 9 over 9, and this is going to be 7 over 7. So I have 45 63rds and 35 63rds. So now I'm going to add 45 and 35, because I know that they're all now 63rds. And I'm going to end up with 78. And I don't want to leave out my whole numbers, so I'm going to have 11 and 78 63rds. And I might say, whoa, that doesn't look like something I've seen before. I have a mixed number combined with an improper fraction. And we know that that is not something that we're used to seeing, nor should it be something we get used to seeing. So at this point, we need to do a little bit of regrouping so that we have an answer in a standard form. So I'm going to change this into a mixed number. So I know that 63 goes into 78 one time. So I'm going to carry that 1 over to the 11. So that becomes a 12. And then I have 15 63rds left. I'm just going to double check my math there. So I've got 15 63rds remaining. And I always want to double check to make sure if I can reduce. So I'm looking at 15 and 63. and I'm wondering if I can reduce them both by a factor of 3. So yes, I can. So once I reduce, this becomes 12. 15 divided by 3 is 5. 63 divided by 3 is 21. So my final answer is 12 and 5/21. Notice again up here that I did not change these into improper fractions. My numbers would have been big and hard to work with, and the bigger the numbers, the more mistakes I tend to make. So I want to keep it in mixed numbers and then make adjustments at the end should I need to regroup. So always double check this fraction to make sure that it is a proper fraction, and I'm going to regroup when I need to make it look like a fraction that I'm used to seeing.